Chapter 4, problem number 27. Mars has a mass of 6.46 times 10 to the 23rd kilograms and a radius of 3.39 times 10 to the 6 meters. What is the acceleration due to gravity on Mars, and how much would a 65 kilogram person weigh on this planet? So I wrote down all the given information. Now, to find the acceleration due to gravity, we turn to Newton's universal law of gravitation, which states that the force of gravity between any two masses, m1 and m2, is given by the product of the two masses times the universal gravitation constant divided by the distance between the two masses, center of masses, squared. So filling in here, we'll say that m1 is the mass of the person and m2 is the mass of Mars, and r would be the center-to-center distance between the person and Mars. And then the force of gravity, we know from Newton's second law, we can set equal to the mass of the person times the acceleration due to gravity. That's his weight after all. So this we can write as mg, and then that's equal to gm, mass of Mars, over r squared, which is the radius of Mars. And you'll notice that the mass of the person cancels out, and it leaves us with the acceleration due to gravity on the surface of Mars is equal to g, capital G, the universal gravitation constant, times the mass of Mars, divided by the radius of Mars, or the center-to-center distance between the mass and the center of Mars. So substituting, we have 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Remember, that was determined by Henry Cavendish in 1798. Newton did not know that number. Times the mass of Mars, 6.46 times 10 to the 23rd kilograms, divided by the radius, 3.39 times 10 to the 6 meters. So let's see what g is, the acceleration due to gravity. Now, this is squared, almost forgot. And I'm getting about 3.75 meters per second squared. Now, the person's weight is just m times g. So the mass of the person is 65 kilograms, and the acceleration due to gravity is 3.75 meters per second squared. So we get a weight of 244 newtons, thereabouts.